We're now going to move from vectors in what we call two-space or 2 dimensions to 3 dimensions. But let's review the 2-dimension first. If I was to graph the vector 7, 2, then what I'd have to do is I basically go on my XY axis, move over to 7, wherever that is, let's call it here, and up 2 from there, and create the vector by going in standard position from the origin out to that point and representing the vector. If I wanted the magnitude of that vector, all I have to do is do a Pythagorean calculation on that, where I have 7 squared plus 2 squared, giving me 49 and 4, which is about 53. And that would represent the magnitude of that vector. Now, when we go to 3-space, we have a 3-dimensional diagram where we have our x-coordinate being this diagonal here, our y-coordinate being the horizontal, and our vertical being the up and down. So it puts it in open space. And if I want to locate a point, in other words, the point 2, 7, and 3, these are the x, y, and z coordinates. What I do, again, is I first have to know what is my positive set of coordinates. Well, in this diagram, the positives go out towards us on the x-axis, to the right on the y-axis, and up on the z-axis. So I have to locate those points. In other words, I have to go out 2. So I'm going to go out 2. I'm going to go over 7. And I'm going to go up 3. And this is how I'd start this. Now, graphing these are a little bit tricky, and if you're an artist or have some idea of spatial recognition, it's going to be a little bit easier. So what we're going to do is we're going to take and actually draw parallelograms relative to the axis coordinates. So what I have is I have a length of 3 vertically, and I have a horizontal 7, and I have this outward position of 8. So what I'm going to do is I'm going to go, or outward position of 2. So I'm going to start at the origin and move 2 along that x-axis. And then I'm going to move 7 along my y-axis. Now what I have to do with these 2 lines is create a parallelogram. So in order to do that, I come out. Thus, these 2 sides here are parallel, and then I go straight over. And what I've now calculated or done is drawn the base of this figure that I'm trying to locate the point at. Now, I'm going to draw the back of this. So if I do that, I go on the z-coordinate up 3. And then I draw its parallelogram by moving the same distance up over here, and I'm going to go over that 7. So what I have now is what I'm trying to do is create a prism that looks like a rectangle. All right, and now I'm going to take this axis over here, and I'm going to draw a parallel line relative to the x-coordinate here, and then go up 3. So what I've done is I've created a side, a back, and a base of this box. And then now what I will do is I will create the parallelogram with this line here and this baseline by going up relatively the same distance. Let's call it there, and draw this line over here. And what I have left to do is create the front of this box, so I'm going to move over in this direction. So you'll notice I've created a rectangular prism, and from that rectangular prism I'm going to move 2 on the x, 7 on the y, and 3 on the z. And when I've done that, what I've created is I've created this point out in space. So it's actually coming towards us and it's moved out. And if I was to draw the vector, I'd go from the origin out to this point and that's the vector in 3 space. To calculate the magnitude of that, magnitude calculation is very similar to the magnitude calculation of the 2 space vector, where we're taking a Pythagorean but of actually 3 points. So I've got 2 squared, 7 squared, and 3 squared. And I take the square root of that, so it's 49, 53, and another 9 is 62, right? And that's the magnitude. All right, let's do another one just for practice. I'm going to now graph -3 for the x, so I'm going to notch that off. +5 for the y. And 1 of the negative type for the z. All right, and let's do this one green again. So what I'll do, I think I will create the x and the y again first. So I'll go along the x-axis, that -3, go along the y-axis, 5, create a parallelogram using those coordinates. That's an average parallelogram, doesn't look great. Now I'll move down 1 and move over. So that's that parallelogram. Now what I've got to do is I've got to create a rectangular prism out of this. So I'm going to take this side over here and also construct a parallelogram. So as you can see, I've got the top, the side, and the front of this box. And what I'll do now is I'll create the back of it. So I'm going to go down approximately 1 here and move over. So that's the back of that box. And to finish it off, I'm going to do this side over here, create its parallelogram. All right, and you'll see that I've got everything I need now. I'm going to go back 3 for the x, out 5, down 1, which is going to put me right on this yellow dot. If I want to draw the vector, there I am. Okay. And then once again, to find the magnitude, I just take 3 squared, add it to 5 squared, and 1 squared. Obviously, these negatives aren't going to make much of a difference, but I'll put them in anyways. Square root that whole guy. You've got 9, 34, 35, and that's your magnitude. So we're going to use these 2 points to represent the vector AC, and we're going to use our tip minus tail method again. If we name our vector AC, C is the tip, A would be the tail. So I use tip minus tail once again, and I'll have 6 minus -1 for the x component. I will have 14 minus 2 for the y component. And then for the z component, I will have -2 minus 7. Thus giving me a vector of 7, 12, and -9. If I write this in terms of unit vectors, notice the unit vectors down here. I represents 1, 0, 0, J represents 0, 1, 0, and K represents 0, 0, 1. So this would be 7i plus 12j minus 9k. To add these two vectors, I do basically what I did in 2-space. So we're going to take the scalar multiple of 4 and multiply it by x. So 4x is going to be represented by 8, 48, and 0. 3y is going to be represented by the vector negative 24, 12, and 21. And now I'm going to subtract these. So if I go 4x minus 3y, that's going to be represented by the following vector of 8 plus 24, 48 minus 12, and 0 minus 21, which gives me 32, 36, and negative 21. And if I wanted to put that in unit vector form, that's 32i plus 36j minus 21. Okay. And that's all we've got for today. Here are your questions that you need to answer, and we'll talk to you tomorrow.